Welcome to the channel. I'm Mrs. R. Let's do some math.
Today we're talking about finding slope from an equation. So we've already had some videos, if you're going through this series in order, about finding slope from a graph, finding slope from 2 points, and now we're going to look at finding slope from an equation. But before we get too far into this, I want to talk about the 3 different forms of a linear equation. Now, not every linear equation you'll work with will start out in these forms, but these are the forms that are nice and helpful for us and what you do in your Algebra 1 class. Now, the first form you're likely to learn is slope-intercept form, which is y equals mx plus b, and it's called slope-intercept form because the slope is represented by m, and then the y-intercept is represented there with the b letter. So it's easy to find the slope and the y-intercept. That's why it's called slope-intercept form. Then the next form you will typically learn in Algebra 1 class is standard form. This is ax plus by equals c. Notice the a, b, and c are capital letters because those are always going to be whole numbers. If it's official standard form, they'll be whole numbers. Where this form tends to be useful is when both things are changing and they're changing at a constant ratio and you want to kind of manage that ratio. This is a nice easy way to see it. Then the third form that some Algebra 1 teachers will teach, some won't, is called point-slope form. Now, I like this one a lot because it's really helpful. Obviously, there's slope there still, and it's still m. We're nice and consistent that way. But then you can also use this when you know a point or you want to find a point. Usually it's when you know a point and you're trying to work on things. But this h and x, those are the parts of a point that's on this line. So there is a video about the point slope form, specifically how to use it, how it's helpful. But for today, our easiest way to get an equation to the point where you can easily identify the slope is going to be from our friend slope-intercept form, the y equals mx plus b. So that's going to be our focus here. If we can get these equations, no matter what they look like, into this form, where y equals is on its own, y is all by itself on one side of the equation, we have one number here with x, one coefficient, and then we have something that's added or subtracted at the end. That's fine, but our focus will be on what is this number. Once we have this form, what is this number that's being multiplied by x? That's our slope. So let's try some examples. We're going to find the slope of each line based on its equation. So remember, we're looking for this form. Y by itself equals coefficient of x plus b. We're looking for what is this number that's being multiplied by x. So first we look at this equation, y equals negative 5 halves x. And we see the y equals all by itself. Okay, so that's a good thing. We see a number multiplied by x, so we have that mx format. And then we have just a constant number at the end. We are in slope-intercept form, so that's a good thing. That means that whatever this number is right in front of x, the number that's being multiplied by x, that number is our slope. So if you're given an equation in slope-intercept form, it's actually really simple to find the slope. You just use the coefficient of x. Now here's the one time where it's not quite as easy. I still have slope-intercept form here. I have my y equals by itself. I have a constant. Now it's subtraction, but that's okay. It's still a constant number, no variable at the end. And then there's the x here, but we're supposed to use the number in front of it, and I don't see a number in front of it. This is where you have to remember that when we're talking about coefficients and variables, if the coefficient is 1, it doesn't have to get written down. So there is an invisible 1 there. Anytime we don't see a coefficient, the coefficient is 1. And since the coefficient here is our m, or our slope, that means the slope of this line was 1. Now, let's keep going. We got to make it a little more complicated each time. So this next one, we're kind of in form, I guess. We have y equals by itself. That's good. We have constant by itself. That's good. But then we're looking for the x, and it's not even there. So now we have to think about, okay, what slope, what coefficient would be on x that would make it just disappear? Well, we know a coefficient of 1. We'd still have to write the x because there is one x there. But if the coefficient were 0, then there's no x's. And that's where we get this idea of just y equals 7. There's no x's there because the coefficient was 0. There's no x's. So this is a 0 slope. Slope equals 0. If you think about how this equation would graph, we've talked about those 0 slope lines before where they're horizontal. Let's say here's our 7, right? If this equation says y equals 7, that means it doesn't matter what your x coordinate is at all. X isn't even in the equation. So we could have a point at 1, 7. We could have a point at 5, 7. We could have a point at 12, 7. As long as the y value is always 7, then your point will be on that line. And that's what gives us that horizontal 0 slope line. So there we go. If you just have y equals, that means it's a horizontal and your slope is 0. Now, the next one, we have a little work to do because there is an x here, but we're not in slope-intercept form yet. Because look, here's our y equals, but it's not by itself. So the first thing we need to do is get this y by itself. We need it to just be y equals and then have the rest of whatever over on the right-hand side. So now we have to think about how do we get that y all by itself? Well, we are going to use our inverse operations to get rid of anything that's on the same side as y. And remember, when I say same side, I mean the same side of the equal sign. Y is on the left. The 2x is on the left. That's what we want to get rid of. Now, this is a term altogether. I'd like to just move the whole term together if I can. And terms we move or remove by adding and subtracting. So since this is a positive 2x, the easiest way to get rid of it will be to subtract 2x. Now, it does mean I have to subtract 2x on the other side. But on the left, if I had 2x's and now I've taken away 2x's, that will cancel to 0, leaving us with just y, which is perfect. Now, on the right-hand side, it is very tempting to think about 1 minus 2. I understand that. But these are not like terms. So we have an x here. So our 2x, that is a variable term. It's actually a linear term. But this 1 doesn't have a variable at all. So we can't actually do this subtraction. We just have to write it back down. So we have 1, and then we have a minus 2x. So we're really close to being in slope-intercept form. We're just not quite perfect yet. And you might be able to tell what the slope is already just from what we've said before. But if we want to get it into perfect slope-intercept form, we need to make one more change. We need to use the commutative property. And part of that is realizing that subtraction is the same thing as adding a negative number. Once we realize that, addition is commutative, and I can flip-flop these. I can put my negative 2x first, and then my positive 1 second. So I realized that subtraction was adding a negative, and I used the commutative property of addition, and now we are perfectly in slope-intercept form. I have my y equals all by itself. I have my x term with my coefficient here. I've got just a constant number at the end. But remember, the answer we're looking for is that coefficient on your x term. So our slope here is negative 2. All right, just 2 more examples. We've got another standard form one here. 8x minus 3y equals 9. And then we have one that's just kind of random. We just have a bunch of terms that's not in any particular form to start. But for both of these, converting them to slope-intercept form is going to be our best plan of action, because then it's the easiest way to see what our slope is. So let's focus on the left. 8x minus 3y equals 9. Now remember, our goal right now is to get that y equals all by itself. That's the goal. So we're going to need to clear out everything that's on this left-hand side, which means we're going to have to get rid of the negative 3. We're going to have to get rid of the 8x, all kinds of stuff. Now, we've got options. We could get rid of the 8x first. We could just get rid of that term like we got rid of the 2x in the last problem. We could try and handle this negative 3 first. I don't think that's the best idea, though, because this is negative 3 is multiplying by the y. You can't see it, but since it's right next to it, it's multiplying by the y, which means to get rid of it, we would have to divide by negative 3, which is going to work out fine with our negative 3y term, and it's going to work out fine with the 9, but when we have to divide the 8x, that's not going to work out nicely. So I would much rather save that for the very last step so it doesn't affect any of our other steps. So out of all of our options, I would like to handle this 8x first. Now remember, this is a positive 8x, so when moving or removing terms as the whole term, we are either adding or subtracting. That's positive, so we're going to subtract 8x from both sides. 8x minus 8x, because it's going to cancel to 0. We'll have negative 3y. Now remember, on this right-hand side, we can't actually subtract 9 minus 8x. They're not like terms. So we just have to write it as 9 minus 8x. Now we can go ahead and do our division, and it's going to still not work out perfectly, but it's at least one of the last things we're doing. So we're going to divide by a negative 3, because this originally said negative 3 times y. We want to do the opposite. And we're going to divide these by negative 3 also. So here's how this is going to work. On the left, negative 3 multiplied and then divided cancels out to just give us y. Here, though, the way we're going to handle this is actually split this into two different fractions. Since we have this subtraction in our numerator, that means we can split this into 9 over negative 3 minus 8 over negative 3. Sorry, 8x over negative 3. So we basically undid a fraction, subtracting fractions with common denominators. It's not a very common step that people like to write out, but that's what we can do here. And it's actually really helpful because then 9 divided by negative 3 works out really nicely. We end up with y equals, hey, negative 3. 9 divided by negative 3 is negative 3. Then we have minus. Now we worked with this idea in a previous video about slope. With a negative in the denominator, that's not typically how we want to represent our answer. We like to represent that as the fact that a positive number divided by a negative number will give us a negative result. So we're going to write that as a negative fraction of 8x over 3. Now, we do have some awkwardness here with subtracting a negative. So as far as rewriting this, let's go ahead and change that to y equals negative 3 plus 8x over 3. Okay, we're still not quite perfect into slope-intercept form because right now we have our x as the back and we need it more in the front if we're going to match this perfectly. So I'm going to use the commutative property of addition here to flip-flop these terms. So y equals. Now our 8x over 3 is the same as 8/3 times x. So we're flip-flopping. That'll go there. Negative 3 will come over here, which means we have minus 3 instead of plus 3. Now, ultimately, we can't lose sight of what our goal was, right? Our goal was to find the slope. And now that we have this in slope-intercept form, slope is the coefficient on x. The y-intercept is -3. We don't need that right now. But that means our slope here is 8/3. So our line, for every 8 units that it rises, that it goes up, it goes over, or it runs 3 units. All right, just one more example. This one's a little weird, but it's good to practice the weird ones. So remember, our goal again is to get this into slope-intercept form. So eventually we're going to have y by itself equals whatever. So I want to kind of focus in on where my y actually is. Then all the rest of this junk, all the rest of this we want to get rid of. So let's see what we can do. Now I have this -2 I'll need to get rid of. It's -2 times y. I've got a -10 as a constant term. I have a positive 2x as a linear term. And I need to get rid of all of those things. So I think to keep consistent, let's go ahead and do our addition or subtraction of terms first. Now I can actually consolidate this. So I can add 10 to both sides. And I can subtract 2x from both sides. Now, if you're more comfortable splitting that into 2 different steps, that's absolutely fine. But either way, you should end up -10 plus 10 cancels to 0. 2x minus 2x is going to cancel to 0. So that left side, we're left with just the -2y. Now, on the right side, of course, none of these, well, the 0 and the 10, I guess, are like terms. So we can do 0 plus 10. But the 10 and the -2x, those are not like terms. So we still just have to write them out. We can't actually subtract them yet. And now we are ready to get rid of this -2. And it's -2 times y. So we're going to divide by the -2. So our -2's will cancel, leaving us just with y equals. And again, just like the last one, I'm going to split this into 2 individual fractions. So 10 over -2 minus 2x over -2. 10 divided by -2 is -5. And then we have a 2 divided by -2, which would be -1. But we've got this negative thing happening again. So y equals -5 plus 1x. Oh, but that 1 is that coefficient that I don't really have to write. But since we're working with slope here, I'm going to go ahead and leave it. I do want to finish this into slope-intercept form, so I'll use the commutative property of addition and flip-flop these terms. So I have 1x minus 5. And then 1 is our coefficient on x, so our slope is 1. So hopefully by now you can see how helpful that slope-intercept form is in finding the slope of a line. Now, I will tell you, we didn't always have to get this into the perfect slope-intercept form to find our slope. We had the 8/3 right here. We had the 1 right here. We took an extra step, really. Here, we had the -2 already. Here, we kind of, this is just one that you'll probably start to remember. If there's 0 x's there, then it's 0. But sometimes you can see what that coefficient's going to be before everything's completely perfect. Just be careful to make sure that your y is completely by itself before you start deciding what your slope is. So that is the basics of finding slope from an equation. Just convert your equation, do whatever algebra steps you need so that it looks like this y equals mx plus b form, and then your slope is just the coefficient of x. If you found this video helpful, please like the video, leave a comment if you want. If you'd like to see a different concept made into a video, please leave a comment. Any kind of interaction helps us get these videos out to more people so that they can get help too. Thanks a lot for joining me. I'm Mrs. R, and this has been Me Doing Math.